Good evening to all and welcome to Byju's IAS. This is Basavaraj. So, we will be continuing the disaster management where we have stopped yesterday. So, hope I am audible as well as visible to you all. Please confirm that. Good evening to all. A warm welcome. Right. So, please confirm that I am audible as well as visible to you all. Yeah. Am I audible and visible so that I can start the class? Perfect. Okay. So, we'll start the session from where we have left. So yesterday we discussed about the forest fire, and I told that the reason for forest fires, the causes for forest fires are natural as well as man-made. And the man-made we refer them as anthropogenic factors. And the natural are like lightning, volcanic eruptions. So natural, man-made. If it is uncontrolled forest fire, then that can create huge losses. We refer that as a disaster. If it is controlled forest fire, then it is advantage to the forest ecosystem or grassland ecosystem. This is what I told yesterday. Advantage for ecological benefit of the forest biome and the grassland ecosystem. Apart from that, we discussed that the droughts, the heat waves, are also one of the reasons for the forest fires. And due to the global warming and climate change, we find the incidence of forest fires are increasing. And due to the impact of global warming and climate change, there has been change in the monsoon patterns as well. So this precipitation patterns is also having an impact on the forest fires and its spreading aspects. If there is delay in the monsoon, then the forest fires become more dangerous in northeastern part, northern part. So they become inevitable because of dry vegetation if it is delay in the monsoon. And apart from that, the droughts will also make the vegetation completely dry, and that is where the forest fires are inevitable and they spread very fast due to wind and other factors. So this is something which we have read. And apart from that, it is monitored by something called as MODIS as well as SNPVIRS. So here we are using the FAST 3, Forest Alert System 3, which is providing real-time monitoring. Real-time monitoring, right? Now, next is about the forest fire management in India. Now, UPSC may ask a question on that. Write a note on forest fires and what are the forest fire managements are there in India. So here we have legal aspects and certain policies are there. So we have acts and policy, which can be very important in preventing or reducing the impact of forest fires. The first one is the Act, Forest Act of 1987, which says that it is a criminal offense to burn or allow in reserved and protected areas. So, protected areas means national parks, wildlife sanctuaries, biosphere reserves, etc. So, we refer them as protected areas. Then, Section 30 of Wildlife Act of 1972, that is after independence, after 1947, it prohibits the setting up of forest fires in the wildlife sanctuaries, right? Then clearance of the forest lines and conduct controlled burning. Now, when we do the forest clearance of the forest line and controlled burning, it will reduce the threat of major impact. So it will reduce the threat of huge fires, because when there is controlled burning is done periodically, they keep on burning the dead branches of the tree, dead leaves, so it will not accumulate. So it will reduce the threat of huge fires. Plus, when we make a controlled burning and clearance of the forest, it will make the movement of forest officials and animals in the case of emergencies. So it will make easy for movement of officials and animals. And this is very important, right? It is very important. The reason is, when the passages are free during the fire or during the emergencies, they can make the safe exist from the forests, or the disaster management can reach to the destination very faster. Then selective thinning and plantation of fire resistant plants, we refer that as silviculture. So if you make the thinning of the forest, then it will not spread very fast. So it is about controlling the crown fire. It is about controlling the crown fire, right? So crown fire means which spreads through the leaves and branches of the trees. If the forest is very dense, easily the crown fire will spread. So it is to control the crown fires. It is to make sure that the forest is safe from any type of the blazes. Apart from that, when we make the fire resisting plants, so they will recover very quickly. They will recover very quickly. If they are burnt also. Then early warning system and fire danger rating system. So at present we are using the fast 3 fire alert system, and real time monitoring are being done. Real time monitoring is done, right? So selective thinning means trees branches will be cut so that the continuity of the forest vegetation is destroyed. Then dry fire fighting techniques, it is something called as bush fightings. Sometimes when the surface fires or ground fires are there, so we use small branches of the trees, we use the bush, and by that we can reduce that. So it is to control the ground fire. Ground fire, we refer that as the dry fire techniques. Apart from these, we have something called as National Action Plan on Forest Fires. Now, this is something which is very important. They may ask a separate question on, write a note on National Action Plan on Forest Fires. Now, the major aim of National Action Plan for Forest Fire, the major aim of this is minimize the forest fires by informing, enabling, and empowering, enabling and empowering the fringe communities. So fringe communities means those communities which are near the forest. So those communities which are at the boundaries of the forest, we refer them as fringe communities. Fringe communities. And here the major objective is giving incentives to work with the forest officials. It is giving incentives. Giving incentives to work with forest officials. So it means the local people should be involved in forest fire management. So that is the aim of the National Action Plan for Forest Fires. Now, what are the principles of the National Action Plan for Forest Fires? The first one is, it is to guide and assist. Now, whom are guided and whom are assisted? So it is to guide and assist the policymakers, the administrators, and the local people in that areas. So we refer them as the civil societies. Civil societies, right? So it is to guide and assist policymakers, administrators, and civil societies for holistic management of the forest fires. The second one is prevent the forest fires and improve the resilience against the hazard. Now, here we come across a term called as resilience. So, what do you mean by resilience? The moment when the word resilience is there, it consists of the first part, which is referred as providing resistance. Resistance. Resistance to the forest fire. And the second part of that, it means resilience means resisting in the beginning. If it is unable to resist, then it will get damage. So in that case, it should recover very quickly. That is called as resilience. Recover quickly. Quickly. So henceforth, when you are writing any answers in the disaster management, you should remember resilience is a key term. Resilience means resisting to the impact. And if it is unable to resist the impact, then it will have a loss. And it should recover very quickly. If it performs both these actions, then we refer that as resilience. I'm repeating, if it performs both the actions, resisting and recovering quickly, we refer that as resilience. Recovering quickly, we refer that as resilience against the hazards. So that is where we talk about the prevent forest fires and improve resilience against the hazard. Now the major idea is to conserve the biodiversity and wildlife. Conserve biodiversity and wildlife, right? Then safety of the people. So here in the forest, we always find the tribal peoples are there and the fringe communities are there. So high priority is given to the resistance, sorry, to the local residents. So high priority to the residents. High priority to residents who are in the forest area and the fringe communities. Tribal peoples and the fringe communities. So high priority should be given to them, the tribals and the people who are staying in the fringe communities, right? Then clear line of command should be there. Now this clear line of command can be seen only when we provide responsibilities, and these responsibilities will increase the accountabilities, right? So hence clear line of command will provide responsibility, and this responsibility will define something called as accountability. Accountability. So remember this. So any program which is having accountability, so it means it will be very effective. So this will make the plan effective, right? Then district should be made as a basic units, not the state. District, the smaller part, more smaller, more accuracy can be done. So that's why we are having district plans. District plans reduce that to very small area, right? Apart from that, fire risk zoning and mapping is very important. So as this area is always associated with the drought or maybe sometimes deforestation, etc., so hence it is always important to update the data. So we have to make updating the data. Always we should make updating of the data, and along with updating the data, we should also see that what were the reasons for the previous fires. So hence review is also very very important. Updating the data and review. Then create awareness and effective communication. So this is where we use different apps, we use different media, so that the communication is done properly. So awareness is created by many methodologies. It means that creating a strong leadership, creating knowledge base. So it means that more emphasis should be given on non-structural measures. Non-structural measures. Then forest biomass management. So forest biomass means the dead leaves, dead branches of the trees, we refer that as biomass. So burning them will reduce the high risk. So it is burning of the dead leaves, dead branches, etc. Right. Then weed management. So if weed management is done, then the ground fire will not spread. It is to control the spreading of fire. Then we should always have updated warning systems. Update the early warning system. Early warning system. Right. Now we have started using the satellites from 2010, and at present we are using real-time monitoring, which is Forest Alert System 3.0. So adapt the forest alert systems, improve the ground-based detection, and involve the local people. Involve the local people. So these all are referred as the National Action Plan in the context of forest part. Right. See, they are dictionary meanings. So when we say accountability, accountability means if you are assigning work to somebody, then they should give what is the reason why they are not completed that. You should have that basic idea of dictionary English at least, right? So when we talk about line of command means you are assigning something. So when something is assigned, we refer that as a line of command. And when they are not able to do that, we refer that as accountability. Right. So this is something which is referred as the forest fire national action for forest fires management. Role of real time monitoring. So role of real time monitoring is sometimes when the forest fire catches in the deep forest areas, so you are unable to see that unless and until the smokes are generated. So it gives an idea about the incidents, so that the disaster management can reach there before the events have occurred, because sometimes you find the smokes which is in many areas, so it will give exact area where the event has occurred. We refer that as a real time monitoring. Next, we move on to a next disaster, which is referred as a tropical cyclones. See, current affairs topics, you have to be very clear. You have to be very clear. If you are reading at least 2 years data, that will help you a lot in the context of your preparation, right? So you have to take from any magazines, you have to take it from daily newspapers, and then you link that with your basics of geography and disaster management. Right. Now we move on to tropical cyclones. So what are tropical cyclones and how they are making an impact on the disasters? So tropical cyclones are the cyclones which are found in between the tropical areas, that is Tropic of Cancer and Tropic of Capricorn. Cancer and Tropic of Capricorn, right? And these tropical cyclones, they are low pressure centers. Low pressure centers. Apart from that, the wind is rotating. So it is low pressure center with rotation of the wind. And hence, They are referred as cyclones, that is coils of snake. Cyclones means coils of snake, right? So a definition is irregular wind which rotates around the low pressure center due to atmospheric disturbances and the rotation of an earth. And the rotation of earth is responsible for providing Coriolis effect. And because of these combination, it starts rotating and lifting up. And we refer that as a lifting air with rotation, that is coils of the snake or cyclones, which has been derived from the Greek term called as cyclos. Cyclos, right? Now, on the basis of their geographical location and the development, the reason for their formation, we have two types of cyclones are there. The one cyclones which are found in the tropical areas, we refer them as tropical cyclones. And the cyclones which are found beyond the Tropic of Cancer and beyond the Tropic of Capricorn, we refer them as temperate cyclones or mid latitude cyclones or extratropical cyclones. I'm repeating, the cyclones which are found beyond the Tropic of Cancer and beyond the Tropic of Capricorn, we refer them as temperate cyclones, mid latitude cyclones, or extratropical cyclones. Now, in this discussion, I'll be discussing about the tropical cyclones, which are associated with the disaster. Now, there are many reasons for the development of tropical cyclones. Many factors, many conditions are there. Out of the conditions, the important condition is temperature. Important condition is temperature, right? So, for the development of the tropical cyclones, the average temperature should be at least 27 degrees centigrade. So, as the temperature is the major criteria for development of tropical cyclones, we always say the tropical cyclones as thermal in origin. We always say they are thermal in origin. It means temperature is the major criteria for their formation. So this is one aspect. The second aspect is these tropical cyclones, they always need moisture, and this moisture is something which provides latent energy or latent heat to the wind. So this moisture provides latent heat or latent energy to the wind. Latent energy means the hidden energy which is seen. So hence all the tropical cyclones develop on water bodies. They develop on water body. They don't develop on the land. They develop on the water body. They will never develop on the land areas. At least remember these 2 points. Right. Now, apart from that, in the context of climatology, if you are reading your geography part, so temperature is inversely proportional to pressure. Higher the temperature, lower is the pressure. Lower the temperature, higher is the pressure. So hence, if temperature increases, then the pressure decreases. This is what we have seen in the climatology. Please remember this into your framework. So such types of winds which rotates in the tropical areas in between Tropic of Cancer and Capricorn. So we refer that as the tropical cyclones. And they rotate in directions. In the northern hemisphere, they rotate anti-clockwise. So in the northern hemisphere, this is northern hemisphere, they rotate anti-clockwise. Anti-clockwise. And in the southern hemisphere, they rotate clockwise. In the southern hemisphere, they rotate clockwise. So hence remember the rotations are anti-clockwise in the northern hemisphere and clockwise in the southern hemisphere. Is that clear? So this is some rough idea about the tropical cyclones, right? Now next we move on to understand furthermore on this. If you take the tropical cyclones in between Tropic of Cancer and in between Tropic of Capricorn, so they have different names in different basins. So every water body which is referred as basin, so they are having different names. If you take the West Atlantic, it is called as hurricanes in West Atlantic. And East Pacific, so it means they are referred as hurricanes in America, that is North America. And in the West Pacific, that is China, Japan, etc., they are referred as typhoons. In the West Pacific, the same low pressure systems in the China, Japan, we refer them as the typhoons. And in Bay of Bengal and Arabian Sea, so this is an area which is north of equator, and this area is south of equator. So this entire area in Indian Ocean, we refer them as cyclones. In Indian Ocean, we refer them as the cyclones. Then the North Indian Ocean includes Bay of Bengal and Arabian Sea only. North Indian Ocean includes Bay of Bengal and Arabian Sea. South of equator is a part of South Indian Ocean, which is not associated when you are reading the cyclones of India. So when you are reading cyclones of India, it is North Indian Ocean. So the cyclones which are affecting India and the neighboring countries are the part of North Indian Ocean. Is that clear? So this is some basics about the low pressure systems. We refer them as hurricanes, cyclones, and typhoons. All three are the same phenomenons. Is that clear? So please remember these things. They are found both above the equator and below the equator. And these tropical cyclones, they always develop near the equator. They do not develop exactly on the equator because at the equator, the Coriolis effect is zero. So they always develop near equator. They don't develop exactly on the equator because on the equator, the Coriolis effect is zero. Coriolis effect is zero. So hence, they do not develop on the equator. So they develop near the equator, somewhere here. So this is some rough idea about the cyclones, hurricanes, or the typhoons, right? Now, if you take certain important perspectives, they have different wind velocities, and there are different criteria to classify these low pressure systems. In the context of Indian Meteorological Department, IMD, if the wind velocity is 31 to 50 kilometers, then we refer that as a depression. It is not called as cyclones. If the rotating wind velocity is 31 to 50 kilometers, we refer that as a depression. If it is 51 to 62, then also it is called as deep depressions. So that's why a low pressure system which is developed in the monsoon, we say a depression is developed in Bay of Bengal. We say a deep depression is developed in the Arabian Sea. We don't say cyclone is developed because the wind velocities do not meet the criteria of cyclones. But if the rotating wind velocity increases to more than 62, then we refer that as cyclone. Right? So to classify the rotating wind as a cyclone, the minimum rotating velocity should be at least 63 kilometers per hour. We refer that as a cyclone. And if the wind velocity is more than 89 to 117, then we refer that as severe cyclone. And if it is more than 220 kilometers, more than 220 kilometers per hour, then we refer that as super cyclone, like the Odisha super cyclone of 1998. So it is based on the wind velocity which rotates along the low pressure. So again, I am telling you, during the monsoons, we refer them as depressions. We refer them as something called as the deep depressions. Is that clear? If it is more than 63 kilometers per hour, then only we refer that as a cyclonic storm or a cyclone. Then the hurricanes in United States, they are defined on the basis of Saffir-Simpson scale. So the Saffir-Simpson scale is used to define their strength. Simpson scale is used to define their strength. So if the wind velocity is 119 to 153 kilometers per hour, then we refer that as category 1 hurricane. If the wind velocity is reaching to 170 to 208, then we refer that as a category 3 cyclone. If it is more than 252 kilometers per hour, then we refer that as category 5 cyclone. So this is how the Saffir-Simpson scale classify the low pressure systems or the typhoons or the hurricanes or the cyclones into categories, whereas IMD uses them in the form of cyclones, super cyclones, or extreme severe cyclones, or super cyclones in the based on wind velocities. So please remember these two. In prelims, they may ask. In prelims, they may ask about the wind velocities, right? Now, next, very basic, focus on understanding these terminologies. Very basic, focus on understanding. So this is a water body. Maybe it is a ocean or maybe it is a sea. We refer that as water body. And adjacent to the water body, we have a land. This is a land area, or we refer that as continent. So because of the impact of the temperature and all, the low pressure is developed on the surface of water. And low pressure is an area where the convergence takes place. So the air will converge here. And this wind, when it converges, after convergence, it raises up. After convergence, it raises up. Right? So it rises up. Now, as it is rising up, it is acted upon by Coriolis force, which makes the wind to deflect right side in the northern hemisphere and left side in the southern hemisphere. And that is the reason why this rising wind, it acquires rotation. It acquires rotation because of Coriolis force. And when it becomes stronger and stronger, so this low pressure systems, when it is becoming strong, we refer that as it is intensifying. Any cyclone which is becoming strong, we refer them as intensifying. Intensifying means strong part. And when the cyclone has become sufficiently strong, then we refer that as mature cyclone. We refer that as mature cyclone. And this cyclone gets the moisture from the surface of this ocean. That is, evaporation will add the moisture. Evaporation will keep on adding the moisture, which accumulate and enters there. And this moisture provides the latent energy to the tropical cyclones. This moisture provides the latent energy to the tropical cyclone. Now, if you see the structure of tropical cyclone, if you see the structure, it consists of an eye. Right? So it consists of eye region, and it consists of feeder band or rotation band, right? And the region which is surrounding the eye. So this is how the tropical cyclones look like. Eye and feeder band. And the region which is near the eye, we refer this as eye wall. Eye. So eye is the central portion of tropical cyclone. Side we are having eye wall, and feeder bands or rotation bands are there. And in this eye wall region, it develops the vertical type of clouds. We refer them as cumulonimbus clouds. So in the eye wall regions, it develops the cumulonimbus clouds. Cumulonimbus clouds in the vertical region. Right. So this is how the structure of tropical cyclone looks like. Eye will not have any clouds. This eye region is free from clouds. So all the clouds are found near the eye, which is eye wall. So remember, eye wall is a region where we find the cumulonimbus clouds, and these cumulonimbus clouds, they are associated with heavy rainfall. So they are referred as feeder bands because they feed moisture to the cyclones. They feed moisture to the cyclones. So hence they are referred as feeder bands or rotation bands. So this is your geography part. Feeder band and rotation band, which keep on providing the moistures to the cyclones. Now this cyclone, when it has become intensified, when it has become stronger, where it is having eye wall and cumulonimbus cloud. So this entire structure, when it enters on land area, so this entry of tropical cyclones on the continent, we refer that as landfall of tropical cyclone. Landfall of tropical cyclone. Right. So when it enters on the land, we refer that as landfall of tropical cyclone. Now, when it makes a landfall, what are the impacts of that? When it makes a landfall, its impacts will be high velocity winds will be there, because these tropical cyclones, they are having steep pressure gradient, and hence the wind velocity will be very high. So high velocity of winds. High velocity winds. Second, these tropical cyclones, as they are having cumulonimbus clouds, so they provide heavy rainfall. Heavy rainfall. Then third, in the coastal areas, they create floods. Floods in the coastal areas. So this is what the tropical cyclones, when they make landfall, they do these things. And after the landfall, they do not have much latent energy. So hence, if you take the average life of tropical cyclones, it is around 3 to 10 days. Average life, it is 3 to 10 days. It means that it develops, and the moment when it makes a landfall, after that, it ends its life. So this is what the two things you should remember. One is intensifying, that is getting mature, And when the tropical cyclones enters the land area, we refer that as landfall of tropical cyclones. Entry of the tropical cyclones on the land area, we refer that as landfall of tropical cyclone. And the events associated with the landfalls are high velocity, heavy rainfall, and huge amount of floods, which can be the cause of concern, which can provide huge losses, which creates huge losses. Right. So this is where we talk about the losses, disasters due to its severity. More intensive, more velocity of the winds will be there. Is it clear? So please remember these things. Right. Now, next is, if you see the average number of tropical cyclones, so these all are your basics of geography. I'm revising them. If you take Bay of Bengal, the average number of cyclones every year on yearly basis, 6 cyclones are developed in Bay of Bengal, and average 2 cyclones will develop in Arabian Sea, that is in the North Indian Ocean. North Indian Ocean includes Arabian Sea and Bay of Bengal. Then the largest ocean is the Pacific Ocean, and in the Pacific Ocean we find these areas. Right. So Pacific Oceans, it is the largest one, and hence we find more than 50% of the cyclones are in the Pacific Ocean. More than 50% of the global cyclones are there in the Pacific Ocean. And among the Pacific Ocean, the worst hit region is the West Pacific, that is Northwest Pacific, which includes Japan, part of China, and those areas. So the Northwest Pacific is the worst hit area. Among that, the worst hit is the Northwest Pacific, which includes China, Japan, etc. etc. So 36% of the global cyclones are in the northwestern Pacific, right? Then, if you take the southern part of the Indian Ocean, it is having 6 cyclones. So this is South Indian Ocean, which do not include Bay of Bengal and Arabian Sea. So Bay of Bengal and Arabian Sea are part of North Indian Ocean. They are not the part of South Indian Ocean. They are not the part of South Indian Ocean. For example, Freddy cyclone is of South Indian Ocean. And if you take the cyclones of the Bay of Bengal and Arabian Sea, so they are having different names, right? Like Kyar, we are having the cyclones which had a huge impact in these areas. Gaja cyclone, Kyar cyclones, right? So the Oki cyclones, right, which made landfall in the year 2023. So don't confuse. North Indian cyclones are different and South Indian cyclones are different. Is it clear? Then in the Australian coast also we find a number of cyclones. So this is the average formation of tropical cyclones on the earth. Average tropical cyclones which develop on the earth part. So please remember these things, right? So landfall means entry of the tropical cyclones. Velocity, it depends. Sometimes it may be 100, sometimes it may be 120, sometimes it may be 130 kilometers per hour. The rotating wind, when it enters into the coastal area, so the wind velocities of that will be sometimes at the rate of 120, 130 high velocity winds. And these high velocity winds can make losses, huge losses, right? Now, next is what happens or what is the impact of global warming on the tropical cyclones. I told that the tropical cyclones, they are thermal in origin. So it means that If the temperature of the surface water increases, then the low pressure will become very, very intense. We all know that the oceans, they are referred as the carbon sink, referred as carbon sink. And huge amount of carbon dioxide is entering the ocean. And this carbon dioxide, which is a greenhouse gas, which is having absorbing capacity, heat absorbing capacity. And this greenhouse gas, it increases the sea surface temperature of ocean. That is, it increases the surface temperature. And we refer that as sea surface temperature, SST, sea surface temperature. Deep water will not have much change. The surface water will have high temperature. The deep water will not be having much change. Please remember, it is the surface 100 to 200 meters of surface water where the maximum changes will be there. So this sea surface temperature, as its temperature increases. Now, two things happens. Because of increasing of the temperature, the numbers of tropical cyclones increases. So the numbers of cyclones increases, right? Then second, these tropical cyclones are not only increasing the numbers, they are also becoming stronger. Now any cyclone which becomes stronger, so what is the word for strong? How do you define the strong word, or what is the appropriate word for the cyclone which has become strong? How do you define that strong word, or what is the vocabulary word of strong? You should be knowing that. Intensify. Perfect. Perfect. So hence, the moment when the cyclones are increasing, they are not only increasing, they are becoming intensified. So they are intensifying. So rather than mentioning stronger and stronger, mention they are intensifying. They are intensifying. And the third one, which is very, very dangerous, is sometimes to become strong, it will take 3 days or 4 days. It means that the wind velocity, which is say around 100 kilometers per hour, it will take 3 days, 4 days to reach 160 kilometers per hour. I'm repeating. If the wind velocity of tropical cyclone is 100 kilometers per hour, it will take 3 days or 4 days to reach 160 kilometers per hour. This is called as intensification. Now we find that because of large amount of carbon dioxide, there are some cyclones, there are very few cyclones, where the wind velocity is increasing very fast. So the velocities are 100 kilometers per hour. Suddenly in a day, that is in 24 hours time, it has reached to 160 kilometers per hour. 160 kilometers per hour. So it means that they have become strong, but very rapidly. They have become strong very rapidly. And such cyclones, we refer them as rapid intensification. Rapid intensification. So they are also becoming rapid intensification. Intensification. So the definition of rapid intensification is any cyclone, any tropical cyclone, if it increases its wind velocity more than 55 kilometers per hour in less than 24 hours, we refer that as rapid intensification. So please remember the definition of rapid intensification. If it increases its wind velocity at least 55 kilometers per hour within 24 hours, we refer that as rapid intensification, right? So this is the impact of the global warming and climate change on the tropical cyclones, right? SST means sea surface temperature. Sea surface temperature. That is, in the oceans, the above area, 100 to 200 meters, where the temperature is increasing rapidly. The above area, the temperature increases rapidly, and we refer that as sea surface temperature. Below that, at 2 kilometers, 3 kilometers, there will not be much change. But the above 100 meters to 200 meters, there will be huge variations. 100 meters to 200 meters, or sometimes you can say up to 1000 meters also, we find variations. But at the great depth, we don't find the variation. So hence it is sea surface temperature which is responsible for increasing of the tropical cyclones. So they are increasing, they're intensifying, and they're rapid intensified. Is that clear? Apart from that, as the pressure is becoming very steep, so this low pressure is creating high intense floods. So the floods intensity have also increased. It means the height of the water is increasing. The floods or the height of water is increasing. Height of the wave which creates the flood is increasing. And this is making the area more worst. So four things you should remember: increase in the numbers, intensity, rapid, and worst floods in the coastal areas. Worst floods in the coastal areas, right? So this is the impact of climate change or global warming on the tropical cyclones. If they ask, please remember this. Now, if you see the Indian perspective, India is affected by both cyclones, tropical cyclones as well as temperate cyclones. But in India, the tropical cyclones have two seasons. They are post monsoon and pre monsoon. Before the monsoon, that is April to June, and post monsoons, that is October to December. Now, during the monsoons, generally we refer that low pressure systems as depressions. We refer that as depressions. So during the monsoon, so the specific seasons are there: pre monsoon and post monsoons, right? Now, if you see the India's coastal area, the total coastline of India is 7,516 kilometers, out of which, according to National Disaster Management Authority, NDMA, National Disaster Management Authority, it says that out of the total coastline, 5,700 kilometers, out of this 5,700 kilometers is vulnerable to cyclones, tsunami, storms, etc. So 5,700 is the vulnerability of the cyclones in India. Right now, where do you find the maximum cyclones, and where do you find the severe cyclones? Now, if you take the entire coastlines of India, so this region is referred as Andhra coast, or it is also referred as Northern Sirkar. Northern Sirkar, or Andhra coast, or Andhra coast. If you see the shape of that, it is parabolic type or concave types. So this Northern Sirkar is a region where we find maximum number of tropical cyclones make landfall in India. So remember this data: Northern Sirkar or Andhra coast, where we find maximum landfalls of the cyclones are there. Maximum landfalls takes place because of shape of the coastline. Shape of coastline, because as the tropical cyclone is developed, so if the tropical cyclone is developed here, it follows the parabolic path. So the path of tropical cyclone is parabolic. Parabolic. So it moves here and it will make landfall here because of the shape. So due to the shape, maximum number of landfalls will be there in the northern Sirkar. Now, where do you find the severe cyclones falling? If you see this area, that is Odisha and the part of West Bengal. So this region we refer that as Utkal coast, Utkal coast or Odisha coast. So this Utkal coast is something, Utkal or Odisha coast is something where we find the severe cyclones will make landfall. The severe cyclones will make landfall, or super cyclones will make landfall. Because the cyclone stays for a more time here and it will absorb more amount of the latent heat. So hence Utkal coast is always associated with very intense cyclonic activity. Intense means very strong cyclones. If any cyclone is making landfall in Odisha, it means that it will be very strong. If it is in West Bengal, its impact will be very, very high because they will have large amount of latent heat, right? So northern Sirkar, Utkal coast. And apart from that, even the Tamil Nadu coast is also vulnerable. We refer this as Coromandel coast, but it is comparatively less. So in the eastern coast, remember, northern Sirkar, where maximum cyclones will make landfall. The severe cyclones in the Utkal coast, and less number of cyclones in the Coromandel coast, right? Then the cyclones which are there in the west coast. So here we refer them as the Malabar coast of the Kerala, and we may find a few cyclones which make landfall in Konkan coast, and this is Gujarat coast. Gujarat coast. Is that clear? So please remember the names. Please remember the names. Northern Sirkar, Utkal, Coromandel, Malabar, Konkan, Gujarat coast. So this is about the coastal parameters. This is about the coastal parameters in the context of India. Is that clear now? What are cyclones and vulnerability profile of India? So they can be very important in your prelims, and you can use them in your mains parameters also. Now next thing is that we know three events happen when the tropical cyclones make landfall, and they are floods, which we refer them as storm surges, that is floods. The second one is high velocity wind, and the third one is heavy rainfall. Heavy rainfall. Now, what are damages which are associated with that? What are the damages? What are the damages or potential damages? Right. If it is about the floods, it will make the floodings in the coastal areas. So the floodings in the coastal areas, the water, saline water enters into agriculture field. So it will make salinity. It will make salinity of land, right? Then erosion of the beaches. Many beaches get eroded. Then loss of fertility from the large amount of saline water enters there, right? Apart from that, it will also make damages to the infrastructure. So this is the impact of the floods, or we refer that as storm surges. Now, the nature of coastline also affects this. The nature or shape of coastline also have an impact on this. If any coastline, if any coastline is narrow and elongated, we refer this as narrow and elongated, right? So if the water enters here, so impact will be more. So always narrow and elongated coast will have losses more. Losses more. Second, if the coastal area is having high density of population, then it will have huge losses. Density of population also defines. If it is high density, then the losses will also be more. Third one is economic activities in that areas. Economic activities. So if it is more amount of industries, manufacturing units, then the losses will be more here. Losses will be more here. So this defines the intensity of the floods or the losses in the coastal area. So please remember these points. Then wind aspect. The wind velocities are very high. So it will damage the structures like buildings, sometimes the trees, sometimes the electric poles, etc. We refer that as power communication is disturbed. So it will always have structures like buildings which will collapse, injuries and loss of life. It can be to the humans as well as animals. Human as well as animals. Injuries and deaths. Power communication is destroyed. Then destruction of crops, vegetation, etc. So here large amount of trees will fall. So vegetation means we are talking about trees. We are talking about many type of cropping activity in the coastal areas. So such losses will be seen due to the impact of wind. Then the impact of rain is whenever heavy rainfalls are there, so the land area will get submerged, and that will create the contamination of water. So hence there will be a shortage of drinking water, and land subsidence can take place because of high precipitation. And this flooding in area where we find large amount of animals and many domesticated livestock resources, when they die, the carcasses will be always there. Their dead bodies will be there, and these dead bodies are responsible for creating many type of disease in that areas. In the Gujarat, when we talk, there are less cyclones. In the Gujarat, less cyclones. So that's why I have not mentioned that in detail. Right. So this is where we talk about that. Now always remember, it is the coastal configuration or the shape of coastline which defines. So we refer this as coastal configuration, shape of coastline, shape, how it looks like. We refer that as configuration. Is that clear? So please remember these things, which are the potential damages to the coastal areas. Cyclones, their characteristics, three things: storm surges, winds, and rains. Right now, next is disaster management of the cyclones. NDMA, National Disaster Management Authority, and how it is working in providing that. Now, always it consists of structural measures and non-structural measures. Now, in the non-structural measures, for every cyclone, every event, you don't have to keep on explaining. Just understand that it consists of early warning system. It consists of communication and dissemination. Now, what is early warning system? As it is weather based, and it is extreme weather based, extreme weather based. So it is having a very huge impact on early warning system, very huge impact on early warning system. And this is very important part of pre-disaster management. It is very important of pre-disaster management. And this is where the risk management is done. Risk management is done. Among many parameters of early warning system, two things are very, very important. One is naming of tropical cyclone. One is naming of tropical cyclone. Naming of tropical cyclone. Right. Now, what is advantage of naming of tropical cyclone? As the tropical cyclones, the life itself is 3 to 10 days. So there are other parameters. One is to identify, and second, to demarcate them from basin to basin, we name them. But in the context of disaster management, what is advantage of naming of tropical cyclone? So if any cyclone is named, it will make ease of communication between the forecaster. It will do ease of communication between forecaster and the common people. Common people. It is ease of communication between the forecaster and common people. So hence, the naming of tropical cyclone is very, very important in the early warning system. Right now, once you are named the tropical cyclone, once you have named the tropical cyclone, its communication and dissemination is at most part. It has to reach to the people effectively. It has to reach to the people effectively. And this is done either through the news bulletins or radios, etc. So they keep on disseminating the information through the news, through the radios, or through different apps. Apps are there, mobile apps, by which they will disseminate the name of cyclone and its impact. So remember, early warning system and communication and dissemination is important. Then management of the coastal area which are affected by the cyclones. Manage them. It means that you should make sure that they are having preparedness. Preparedness should be there. Then effective implementation of coastal regulation zones. Now, in the context of India, we are implementing the coastal regulation zones of 2018. So please read this in your ecology and environment. So this coastal regulation zone defines the types of activities which are performed there, or types of activities to be regulated. So this coastal regulation zones are very important, which talks about the activities which are restricted and regulated, so that it will not have a huge impact on the coastal ecosystems. Right. Then awareness generation, awareness among the people about what is the cyclone, how to have the first aid characteristics, etc. So awareness of the peoples, we refer them as non-structural measures. Now coming down to structural measures, in the context of structural measures, it includes like nature based solution, like growing mangroves in the coastal areas. Mangroves in the coastal areas. Right. So it will act as a first line of protection. Mangroves are considered as bioshields. Bioshields. Or they're also referred as first line of protection. First line of protection. So mangroves is one such. Then second one is you can construct the walls and barriers so that the floods will not enter. walls and barriers so that the water will not enter. Then third one is construction of the shelters, etc. So generally we refer them as engineering part. So that the impact of the cyclones, the wind, the flood water should be reduced. So it is generally to mitigate the impact. Mitigate means reduce the impact. It is to mitigate the impact. Remember, mitigate means reducing the impact, right? Then apart from that, we are having something called as National Cyclone Risk Mitigation Project. So we'll discuss what is this National Cyclone Risk Mitigation Project. Now, I told you that early warning system and naming of tropical cyclone is very, very important, right? How shelters will help? Shelters will give place for the people who are affected by that. And this is very important aspect of relief measures, rescue and relief measures. So it means you are reducing the impact of that, right? Now, in the context of India, there are cyclone warning systems are there. Three cyclone area warning systems are there, and these are located in Chennai, Mumbai, and Kolkata. They are located in Chennai, Mumbai, and Kolkata. Chennai, Mumbai, and Kolkata. Then four cyclone warning centers are there. Now, they will never ask you the difference between area cyclone warning and cyclone warning centers. Remember that area cyclone and cyclone warning centers. Don't go in depth analysis of that. Cyclone warning centers are there. They are in Ahmedabad, Thiruvananthapuram, Vizag, and Bhubaneswar. So, three, three, and four. It plays an important role in early warning system and dissemination, early warning system and dissemination of the communication. Now, next is the accuracy of weather forecast. These are the content where you have to remember the facts and the content, right? So, accuracy of the weather forecast and their dissemination, reaching to the people is very, very important. It can be through the apps, it can be through the radios, or it can be through any means of instrument. And for this purpose, to make effective and timely dissemination, we have developed a system called as across. And this is called as atmospheric climate research and modeling observation and services. Right. So we have developed this across, which is an upgraded system one, upgraded service system. Now, the major part of that or major components of this across. So remember, across stands for atmospheric and climate research. Atmospheric and climate research. And OSS means observing systems services. Right. So it consists of advanced operational forecast system, to make effective reaching to the communities, always updating the ways in which it can reach to the local people. Then upgrade the sustenance of community communication system with weather services. It is providing the knowledge or providing the forecast with keeping the local people's characteristics, local people's knowledge based, local people's capacity perspective. And it also talks about creating their capacity building and outreach so that to make more resistance, more resistance. So that's where we find early warning systems. It needs the technologies, cutting edge technologies, updated one to have a proper effective part. Next, International Center for Ocean Information, INCOIS, which is in Hyderabad, has set up the storm surge early warning systems. Storm surge early warning systems in the coastal area. So it gives an idea about the surges, right? And the apps which are used are the device which is referred as Gemini, that is Gagan enabled marine instrument for navigation and information. And this Gagan, it is your SNT, science and technology. Gagan is GPS aided global positioning system, global positioning system, GPS aided geo augmented navigation, which talks about Bluetooth connectivity and other ways where it is disseminated. So please read these terms, Gemini and Gagan. Gemini and Gagan. Is that clear? So this is where you have to keep in the mind. Cutting edge, updated. So if you put these words in your answer will have a weightage, right? Don't write entire thing. Just use the words. So we use the device named Gemini, which is effective in communication. That is more than sufficient. This is for you to read and understand them. Don't put all the data. So this is for you to read, right? Then National Cyclone Risk Mitigation Project, right? Now it is always know that mitigation means you are reducing the impact, and this is something which is associated with risk parameters. Now the major things will be you have to make early warning system improvement. You should increase the capacity of the local people, right? And you should always make effective communication. These all are nothing but the risk mitigation projects, right? So the objective of this national risk is to reduce vulnerability of the coastal areas. So reducing vulnerability means you are increasing their capacities. So it means you are increasing their capacities or increasing their strength. You are increasing their resources. Now, how this is done? One is improvement in the early warning system, and that's why we are using Gemini, Gagan, etc., updating them. Then enhance the capacity of local communities by providing them leadership, knowledge, etc. So, capacity of local communities. So, just reconnect the definition of capacity, what I told in the beginning of the class. The first day, I told something about capacity of individual, capacity of local community, right? So, capacity can be awareness, capacity can be in the form of financial assistance, capacities can be in the form of skills, capacity can be in the form of leadership, capacity in the form of knowledge based, capacity in the form of training, etc. So we refer that as capacities. Then access to emergency shelters, right? So it is where it helps in proper aspect of rescue and relief. Emergency shelters are required. Then strengthening the disaster risk management capacity. So please understand that. So when I discussed about something called as risk is identifying that in the beginning, and disaster risk capacity is assessing that and proper strategies using proper strategy to reduce the impact of that. So hence it has to be done at all the three levels: center, state and local level. Center, state and local level, increasing their capacities. Then mainstreaming the risk mitigation process with the development activities. So all these things we have seen in the first day class itself. The same things are repeated here. The same things are repeated here. So please remember these parts. It is called as the National Risk Mitigation Project, NCRMP. Right. Now, four-stage cyclone warning system. How the cyclone warning system is given? It is given into four parts. That is free cyclone watch. And this free cyclone watch, it provides data about warning or development of cyclone. So this is issued about warning of development of cyclones. And this is generally given to the fishermen's. This is given to the fishermen's. Right. Then cyclone alert. Cyclone alert talks about location and intensity of cyclones. Where the cyclone is developing, location and intensity of cyclone. And this is also given to the local community and fishermen. Local community and the fishermen. So that the fisherman will not enter into the ocean. And this is given 48 hours in advance, 2 days in advance. Then we are having cyclone warning. And this cyclone warning is given 24 hours in advance and once in every 3 years. After every 3 hours, it is given. If it is 9 a.m., then 10, 11, 12 a.m., then 3 p.m., etc. So every 3 hours interval, cyclone warning is given. And this cyclone warning is forecasting the landfall point. It is forecasting the landfall point. So landfall point means where it enters, whether it is entering into northern Sirkar, whether it is entering into Utkal coast, or whether it is entering into Coromandel coast, right? So it gives some idea that where it is making the landfall point, areas within that. Then post landfall outlook. This post outfall landfall is, it is given 12 hours in advance, and this gives the expected time of landfall, whether it is afternoon, whether it is in the night. So it gives expected time of landfall. Expected time of landfall. Is that clear? So these are the four stages of cyclone warning: pre-cyclone watch, cyclone alert, cyclone warning, and post landfall outlook. So they may ask this for 10 marks in your geography or in disaster management, right? And different color codes are there for them. Different color codes are there. That is, if it is cyclone alert, for that they use yellow color code. So while delivering the cyclone alert, it is yellow color code. If it is cyclone warning, then they will use orange color. If it is post landfall, that is giving the expected time of landfall, they use red color. Red colors are there, right? So the pre-cyclone watch is, it gives an indication that a tropical cyclone is being developed in Bay of Bengal or Arabian Sea, where it is developing, either in Bay of Bengal or Arabian Sea. And this is issued by the Director General of Meteorology. Yes, there will be a cyclone in the Bay of Bengal or Arabian Sea. It may be 4 days advance or 5 days advance. Possibility of development. So it is possibility of developments of cyclones. After that, cyclone alert is given. So this cyclone gives the location that yes, it is developed in the north of Bay of Bengal or south of Bay of Bengal. So it gives the location of that. Then cyclone warning. Cyclone warning is given 24 hours in advance. It says that where the cyclone will enter into the coastal area, whether to the Tamil Nadu coast, Andhra coast, or it will enter into the Odisha coast. We refer that as cyclone warning. And the last one is post landfall outlook. So it will give exact date, exact time, whether it is in the afternoon session or whether it is in the night where the landfall will take place. So we refer that as four-stage cyclone warning systems. Yes, red, yellow, and orange. Now, first understand the cyclone warning system, right? So, first understand this, Sony, that this is about the cyclone warning system. Cyclone warning system. Now, whenever cyclones are there, this cyclone will create some impact. It will change the weather of that area. It will change the weather of that area because rainfalls will be there, high velocity winds will be there. So, hence, to describe the weather of that area, the color codes are used. This is what the Kerala gives. Color codes. So color codes are based on the weathers. And this weather is something due to the landfall of tropical cyclones. So don't get confused. Weather related colors are also there. And these are with reference to the cyclone part, yellow, orange, and red, which is about alert, warning, and outlook. And if they are talking about green, yellow, orange, and red, it means that it is about the associated weathers. Is that clear, Sony? So when we talk about these things, you should be very, very careful. So Kerala, Tamil they will say that this is the weather alert. Weather alert. If they say yellow, be aware and be prepared that heavy rainfalls will be there. If they say red alert, it means that take an action. Human life is under threat. Don't move out of the homes. So heavy rainfalls, high velocity winds will be there. So this is the concern weather associated with the cyclone. So when the cyclone makes landfall, it will affect the weather. So it will be in the form of wind. It will be in the form of rainfall. And we refer that as the color code associated with the weather perspective of the cyclones. Is that clear? So please remember two parameters, right? So we can have a break. We can have a break, and we'll start the class at 6:40. We'll start the class at 6:40, right? Is there anything where you are having any difficulty in understanding this about color codes? One is with reference to the landfalls of tropical cyclone, and one is associated with the weather associated that is after the after the landfall, the rainfall, and these things. Is that clear? Okay. So we'll make it at 6:45. We'll start the class at 6:45. Welcome back after a session. So hope I am audible as well as visible to you all, right? Okay. Now color code is given by Indian Meteorological Department. Color code is given by Indian Meteorological Department, right? So hope I am audible as well as visible to you all, right? Okay. So next we move on to earthquake. Earthquakes, right? Now this earthquake is a natural disaster, but it do not have any early warning system. So it is a natural disaster, but the major problem with the earthquake is there is no early warning system for this. No early warning system can be created for that. No early warning systems. We can identify the earthquake prone areas. We can identify the earthquake prone areas, but we can't exactly give when the earthquake will start there, right? So earthquake is vibrations or the tremors which are produced on the surface of the earth. They are the tremors or the vibrations which demonstrates the sudden release of energy which is stored in the earth's interior. Sudden release of energy which is stored in the earth's interior. Now if we take this as the surface of the earth, now the point from where the energy is released, the point from where the energy is released, we refer this as focus of the earthquake. And the point which is exactly above the focus, we refer this as epicenter. Epicenter. And from the focus, the energy which is released, and this energy is released in the form of waves, we refer them as seismic waves. Seismic waves. So hence the study of earthquake is referred as seismology. The study of earthquake is referred as seismology. And the areas which are vulnerable for earthquake, we refer them as seismic areas. We refer that as seismic area. The earthquake which are there, right? So it is the vibrations which is produced due to sudden release of energy, and this energy is released from the point we refer that as focus, and this energy which is released is always in the form of waves, and we refer that as seismic waves. Now when the energy is released, it means that it will break the rock strata, and this rock strata which is broken, the rock strata which is broken, we refer this as fault line. Fault. So in geography, fault means break. Break. Now from the epicenter, sorry, from the focus, the energy is released in the form of waves. It is in all the direction. It is in all the directions. And these waves, which are developed from the focus, which are developed from the focus, we refer them as body waves. We call them as body waves, which originate from the focus. And these body waves are two types. They are the P waves, which can travel in the solid medium and which can travel even in the liquid medium. And they travel very fast. They travel very fast. In the solid medium, they travel around 11 to 12 kilometers per second. And in liquid, their velocity decreases. They travel at 5 to 6 kilometers per second in the liquid medium. In contrast to that, the S waves, they can travel only in solid. Only in solid. And they travel at the rate of around 5 to 6 kilometers per second. So hence the first wave the first wave which is recorded at the epicenter is P wave, and that is followed by S waves. After the P waves, S wave reaches there, right? So remember the terms: focus, epicenter, body waves. And this focus is also referred as hypocenter. This focus is also referred as epicenter. So these are the terms which you should remember in the context of your study: focus, body waves, epicenter, seismic waves, etc. So we refer them as the terminologies associated with the earthquake, right? Now next is the magnitude and intensity of earthquake. Now what are magnitude and what are intensities? They are the two terms which you should remember. The magnitude is associated with the energy released. It is energy released. And this energy release is measured by Richter scale. It is measured by using Richter scale to measure it, right? Then this is always in exponential value. It is in exponential value. It means to the power of 10. If it is 3, so 3 to the power of 10. If it is 4, 4 to the power of 10. So we refer them as exponential values. And they are always in a scale which is 1 to 10. So this is about the magnitude. Now, the second one is intensity. Intensity talks about the severity of that energy. It means that it talks about the losses, it talks about the injuries. So, hence, magnitude is the impact of the energy, impact of the energy, and it is associated with losses, deaths, injury. Right. So, one is energy released, and second one is the impact of that energy. It means strength of that energy. So, intensity means strength of that energy. And this is measured in modified Mercalli scale. It is measured in modified Mercalli scale. And this is represented in Roman values. In the Roman values. And it is having the value 1 to 12. So the scale is 1 to 12. If it is 1, then not felt. If it is 12, then it is completely damaging that. So this is what the difference between magnitude and intensity. Now any earthquake of magnitude 6 and more, we refer that as major earthquake. Any earthquake which is having a magnitude of 6 or more, we refer this as major earthquake. Major earthquake. Now, any earthquake of magnitude 9 and above, 9 and above, is referred as mega thrust. Is referred as mega thrusts. Any earthquake of magnitude 9 and above, we refer that as mega thrust. So please remember these two terminologies. Right. Apart from that, we always know that there is a difference points which is referred as the focus and epicenter. Now, based on the distance between epicenter and focus, based on the distance between epicenter and focus. We define or we classify the earthquake into three types. If the distance is less than 30 kilometers, that is, if the distance between focus and epicenter, if it is less than 60 kilometers, we refer this as shallow earthquake. Shallow earthquake. If the distance between focus and epicenter, if it is 60 to 300 kilometers, then we refer this as intermediate earthquake. We refer this as intermediate earthquake. Intermediate earthquake. And the third one is if the distance between focus and epicenter, if it is 300 to 600 kilometer, then we refer that as deep focus earthquake. So all the earthquakes are classified into these three categories: deep focus, shallow earthquake, and intermediate earthquake. Among these earthquakes, the shallow earthquakes are more dangerous one. The shallow earthquakes are most dangerous because they are like bomb exploding near the surface. We refer them as the shallow earthquake. Is it clear? Now, when we talk about the intensity part, you should remember that body waves are the waves which are inside the earth. Now, intensity is associated with the role of surface waves. Surface waves. Now, what are surface waves? Understand this. This is the focus and this is epicenter. After the earthquake, after the earthquake, the body waves are developed. Right. So these are body waves. That is P wave and S waves, which originate from the focus. Focus. Now, part of the body waves after reaching the epicenter, part of body waves when they reach epicenter, after reaching epicenter, they convert into surface waves. Not all, not all. Part of the body waves after reaching to the epicenter, they convert to surface waves. Surface waves. So this is the region where the surface waves are seen. So from epicenter, the surface waves will develop. So hence, surface waves will always originate from epicenter. So hence, from this region, the surface waves will be seen from the epicenter and body waves from the focus. From the focus. Part of body waves are converted into surface waves. And these surface waves, once they develop, they never come inside the earth. They start grazing along the surface. They travel along the surface. They travel along the surface. So hence we refer them as the surface waves. Hence we refer them as surface waves. And out of these surface waves, we have two waves, that is love wave and Rayleigh waves. So two surface waves are there. One is love wave and second one is the surface waves. Sorry, the love wave and Rayleigh waves. Now, love waves moves like a snake. This L wave or love wave, it moves like snake. Move like snake. That is zigzag one. zigzag type. Whereas the Rayleigh wave, it is like rolling type, wave type. It is rolling type or wave type. And these two, the zigzag type and the rolling type. So these are associated with destroying the stability of the surface. And this makes collapsing of the infrastructure. So these waves, that is L waves and the Rayleigh waves, which are snake-like and rolling, which is responsible for collapsing of buildings or collapsing of infrastructures, losses of the buildings, and these collapsing of infrastructure, when the collapse there, so they lead to injury, they lead to death of human beings and animals, and they are responsible for huge amount of losses, socio-economic losses are there. Is it clear? So hence the surface waves, if they are stronger, then they will always have huge amount of impact here. Now when the surface waves are stronger, when the earthquake is shallow, so these surface waves will be stronger if the earthquake is shallow, because very less amount of energy is lost by the body waves to reach to the epicenter. So hence the surface waves are very strong if it is shallow earthquake, like the earthquake in Nepal, like the earthquake which was in Turkey and Syria. If you remember the earthquake of Turkey, which led to death of more than 50,000 people, more than 50,000 deaths were there. And if you see the distance between epicenter and focus here, so Turkey is shallow earthquake, where the distance between epicenter and focus was less than 20 kilometers. Less than 20 kilometers. And this created huge impact on that. Even though the magnitude was 8.2 and 8.1, but the losses were very, very high when the earthquake is shallow type. Is it clear? If it is a deep focus earthquake, much energy is lost when the body waves reach to the surface. And hence, a deep focus earthquake will not be having huge impact on the surface areas. So hence it is the shallow earthquakes which are considered as more dangerous. Is that clear now? So part of body waves are converting into what we refer them as the surface waves, right? I have already mentioned, whenever you are reading, please focus on the discussion. When I told what is shallow earthquake, I have told you shallow earthquake is a type of a earthquake where the distance between epicenter and focus is less than 60 kilometers, and these all are your geography parts, right? So hence the shallow earthquakes are always dangerous in the context of earthquake perspective. So don't get confused. Body waves will originate from the focus. Part of the body waves, after reaching to the epicenter, they convert, part of the body waves convert into surface waves, that is love waves and Rayleigh waves, and those are the one which are associated with the snake like movement and rolling type, which makes the collapsing of the buildings, which makes the huge amount of socio-economic losses here. Is that clear? So remember the surface part, right? Now what are the causes for earthquake? Now the causes for earthquake is, we define them into natural one. In the natural, it can be referred as the plate tectonics. Plate tectonic. Earth is made up of major and minor plates. If you see the Earth surface, it is made up of major and minor plates. And the boundaries of the plates, wherever these plates are meeting. So this area, the stress is accumulated, and this stress is released from the boundaries. So hence, wherever these plate tectonics move, these plates they keep on moving because of the convection currents which is developed in the asthenosphere. So these are the lithosphere plates, and they keep on moving. They keep on moving due to the convection currents, and they develop the stress in the boundaries, and this stress is released in the form of earthquake. So plate tectonics is one. Second, sometimes when there is a large amount of volcanic activity, so that is also responsible for that. Volcanic activity which triggers the earthquake, right? So these are natural part. Now apart from the natural causes, we also have man-made causes. Man-made causes. Now in the man-made causes, we also refer them as anthropogenic causes, and generally they are associated with human activity. They are associated with human activity, and hence these man-made earthquakes are also referred as induced earthquake. Induced earthquake. Now remember, natural causes are different. Induced earthquakes are due to man-made activities, and generally they are minor earthquakes. Generally they are minor earthquakes. It means whose magnitude is less than 6. Magnitude is less than 6. Right? But rarest cases are there where the magnitude is more than 6. Rarest cases are there where magnitude is more. Now, if you talk about the present data, we find the number of induced earthquakes are increasing. At present, the number of induced earthquakes are increasing because of increasing of the human activities. Because of increasing of human activities. Now, examples of the man-made earthquakes or induced earthquakes. It can be the construction of dams. It can be mining activities, mining activity, or third, it can be due to something called as nuclear tests, nuclear test, or sometimes due to a technology which is involved in extraction of shell gas called as fracking technology. Fracking technology. So these all are referred as man-made earthquakes. Man-made earthquakes or induced earthquakes. Now, how these have increased and what is the activity of human beings are there? Now, if you take the fracking one, fracking is a technology which is used to extract the shell gas, which is in the Earth's interior. And it is also called as hydraulic fracturing. It is also called as hydraulic fracturing. Now, this shell gas is extracted from shale rock. From shale rock. And these shale rocks, they are porous but non-permeable. These shell rocks, they are porous and non-permeable. non-permeable. It means they will not allow the movement of the liquid. So if it is a big rock, then the mineral or shell gas is accumulated in this way. Porosity means holding capacity of the rock. Permeability means allowing it to move. So hence the shell gas is found at different places here. So economically, it is not feasible to drill and take them separately. So hence, this rock is made permeable. This rock is made permeable. It is made permeable. How? By cracking the rock. We develop the cracks. So the moment when the cracks are developed, the rock become permeable. And then in this rock, the same rock after the cracks, the shell gas will accumulate in one area. And when it is accumulated, it is easy to pick it up. And this technology is referred as fracking or hydraulic fracturing. So generally, this is done with an technology with parameters. So this is the surface, and here we are having the shell rock. Right now, drilling is done. Right. So first one is drilling is done. After drilling, the moment when drilling is done, hot water plus sand plus chemical is inserted down with tremendous pressure. Tremendous pressure. So this pressure is responsible for making the weakening of the rock startup. The pressure makes the weakening or breaking up of the rock. We refer them as fault parameters. Now this pressure breaks the rocks, it will develop the crack, and then it will accumulate the fractures. There it will accumulate, and then this is taken out. This is taken out. We refer that as fracking or hydraulic fracturing. And this technology, where the pressure is introduced with extremely high intensity. So this pressure is responsible for developing of the earthquakes. Now the major problems associated with fracking or hydraulic fracturing is one, it can create induced earthquake. Second, as the chemicals are used, so this chemical can pollute the groundwater. It can pollute the groundwater. So hence, in many countries, this fracking is banned. Many countries, this fracking is banned. And this fracking or hydraulic fracturing is controversial one because of its environmental impact. But there are certain countries which have become very self-sufficient in this. Take an example of US. US, by using the fracking technology, it has become self-sufficient. It has become self-sufficient in oil requirement. So before this fracking technology, US was the largest importer of the petroleum and natural gas. Now after developing the fracking technology, US is no more importer of the petroleum. Now this has changed the global parameters. Now at present, if we take 2024, the largest importer of petroleum and gas is China, followed by India. Followed by India. Now, if you're reading your current affairs regularly, China has large amount of shell gas. China has large amount of shell gas. So China is making all its perspectives to develop the fracking technology. If at all, China develops fracking technology, then China will also become self-sufficient. And once the China becomes self-sufficient, again it will change the global geopolitics. It will change the global geodynamics because much of the money is spent in the import of the petroleum and natural gas. Now, once the China become self-sufficient, then it will be a game changer in the global geopolitics. So that is one point. And after that, India will be the largest importer of petroleum and natural gas. Now, is India preparing any type? Yes, India is also thinking of having the fracking technology. But the major issue with India is we don't have technology, we don't have finance, and third one is it is leading to pollution of groundwater. Pollution of groundwater. So hence, many environmentalists are opposing this. Apart from that, it can also trigger the earthquake. It can also trigger the earthquake. So hence it is challenging in the context of India. Hence it is challenging in the context of India to consider these. And we have the shale gas in Kaveri basin, Godavari basin, in many areas we find. So we find these gases in Kaveri basin, we find them in Godavari basin, etc. But the challenge is this. The challenge is this. So this is all about hydraulic fracking or hydraulic fracturing or fracking, which can trigger the man-made earthquake or induced earthquake. Is that clear? So this is the first one. We refer them as the shale gas and all. Then we moved on to the dams. Now, how dams are responsible? So whenever dams are constructed, when the dams are constructed, it always performs two things. It increases the water level, the increased water level, which will create tremendous pressure on the rock strata. It will create tremendous pressure on the rock strata. And this rock strata is nothing but the lithosphere plates. Tremendous pressure on the lithosphere plate when you store the water in the dams, when you store the water. Second one is as the accumulation of the water is there, so that will make the pressure lubricates the faults and decreases the friction, and hence the rock surface beneath is vulnerable to break. And the third one is these both activities these both activities will make the lithosphere plate to develop a crack, and this crack we refer that as faults. So remember, in geography faults means it will develop a crack, a weak area, and this crack is something from where the energy is released. This crack is something from where the energy is released in the form of earthquake. And there has been a strong major concern with reference to the Mettur Dam, which is a controversial now. So they say that this Mettur Dam, which is constructed, will have, or maybe it will have an impact. So it will create that area. It will create that area into seismic zone. Seismic zone. Controversy about the Mettur, apart from sharing seismic zone. And in India, we have already experienced the earthquake associated with the dams, and that is in Maharashtra. Maharashtra, the Koyna Dam or Koyna earthquake, which is in 1960s. In Maharashtra, we have already experienced the earthquake, which is dam induced. Dam induced, right? So it will increase the pressure, it will decreases the friction, and that makes the rock or lithosphere to break. And the moment when it breaks, energy is released in the form of earthquake. Energy is released in the form of earthquake, right? So this is what you should remember. See, whenever when the pressure is there, when the pressure is there, it will reduce the friction. So the rock starters, they start behaving like loose connectivity. They will reduce the friction of rock and surface beneath. So the rock will try to move downward. And when it moves downward, it is just like if you are attaching two entities with a Fevicol. If the friction is removed, then they will start behaving like two entities. The friction decreases in that. And hence, the upper portion remains as it is, but the rock breaks. The lithosphere, the lower portion breaks here, right? And this is where this area, which is called as faulting, breaking takes place, and which can be any region this way or this way, where it breaks and the energy is released in the form of earthquake. Is it clear? So this is what you should remember, right? So here there is nothing, it is not a geology class where I have to explain that in detail. So understand, whenever the dam construction is there, it will create pressure on the rock strata, and this pressure will make the rock to break. If you remember this point, that is more than sufficient. A pressure, whenever when you accumulate, it will create a pressure on the lithosphere plate or rock strata, and this pressure makes the rock to break, and breaking is referred as faults. Simple as it is, right? And this happened in Koina Dam. So in the Koina Dam, when large amount of water was accumulated, in the Koina Dam, when large amount of water was accumulated, so this rock strata beneath that, it develops a cracks here. It develops a cracks, and then whatever amount of the water which was stored entered into the coastal areas. So if you remember these points, that is more than sufficient. They will never ask you. They will never ask you how the dam is responsible for earthquake. That is your optional geology. That is your optional geology. Just remember, accumulation of the water in the dam increases the pressure, and that pressure is responsible for breaking up of the rock. It is simple physics. When the pressure is there, the rock will break. When the pressure is there, the scale will break. Simple as it is, right? Now, the global distribution of earthquake. So the earthquakes are defined into three major belts. The global distribution of earthquake is defined as three major belts. The first belt is referred as the strongest belt. The strongest belt, which is referred as Alpine Himalayan belt, or it is also referred as Alpide belt. Alpide Himalayan or Alpide belt. The first one is Alpide belt or Alpine Himalayan belt. Alpide or Alpine Himalayan. It is formed when Indian plate collided with the Eurasian plate and African plate collided with the Eurasian plate. So it is collision of Indian plate and African plate which created the strongest plate, strongest belt. And in Alpide belt, we always find shallow earthquakes and intermediate earthquakes. No deep earthquakes are there in Alpide belt, that is Alpine and Himalayan, right? Then the second region is the Pacific Ring of Fire. The second one is Pacific Ring of Fire, right? Pacific Ring of Fire, or it is also called as circum-Pacific belt, ring of fire, Pacific ring of fire or circum-Pacific belt. It is formed when the Pacific plate has subducted beneath the continental plate. So it is the subduction of the Pacific Ocean plate. Subduction of the Pacific Ocean plate in the continental parts. So this Pacific plate, which has subducted, creates the Pacific ring of fire. And this is the region where we find all the three types of earthquake. That is, we have shallow earthquake, we have intermediate earthquake, and we also have deep focus earthquake here. So all the three types of earthquakes are found in this Pacific ring of fire. And the third region, what you mentioned, or what you have to write is all other earthquakes, including induced earthquakes, all other areas, including induced earthquake, induced earthquake. So this is referred as the global distribution of earthquake. If they ask the earthquakes which are in India, that is Nepal, Himalayas, or Delhi, the earthquakes in Nepal, Himalayas, or Delhi. So, what type of earthquakes are there? Shallow earthquake, intermediate earthquake, deep earthquake, all the three, all the three. Right. So here, if you take the Alphite belt, so Alphite belt will have more amount of shallow earthquake, and sometimes it will have intermediate earthquake. Shallow earthquake, and sometimes it will have intermediate earthquake. We don't have deep focus earthquake in the Alphite belt. In the Alphite belt, and it is the strongest belt of the earth. Is that clear? So we refer this as the global distribution of the earthquake. Is that clear? This you have read in your geography. Now, one thing again, don't make in-depth microanalysis. They are not required. They are not required. If it is your optional, then you have to make microanalysis. If it is your general studies, understand the basic points, what it is. Don't go why. Don't go for why. If you keep on going for the why, your content will increase and it is difficult for you to remember them, right? So if it is why, then I would have explained that in detail. So where why are not required, don't go for why. Please don't go for why where it is not required. Only certain things where what is sufficient for you to write the examination. If you keep on analyzing on why factor, then there is a possibility that you may deviate from your strategy of preparation, because that why may be interesting and that interesting point is not important in the context of your exam. Is it clear? So please remember that how to read, what to read, and what to restrict there. If it is very much significant, then I would have explained you why factor also. Is that clear? So please understand, when why is not stressed, don't make in-depth aspect of that. So certain what's are important, right? So the third one is all other, including the induced earthquake. All other means these areas which are intraplates. So we refer this as intraplate. Intraplate. So what do you mean by intraplate? Within a plate. But these two, Alphite and Pacific, they are interplate. These two are interplate. What do you mean by interplate? Boundaries of the plates, where the two plates are meeting. Whereas all the third, induced one, etc., we refer them as intraplates. That is inside the plate, intraplate. Right. So in geography optional, they are not in detail. So they are important for your geology optional. Whatever I am telling, this is more than sufficient in your optional also. This is more than sufficient in your optional. In optional, you have to understand about deep focus earthquake. So in optional, you have to read in detail about Pacific Ring of Fire. Fossais. What are fossais? So when you read them, you come across something called as Vadati Benif zone. So you have to focus on something like that, Vadati Benif zone. So they will ask question on something like this, right? So when you are reading them, Nilanjana, you have to remember certain part like Vadati Benif zone. So they will dig that in detail. They will talk about Benif zone, right, or Vadati Benif zone, right? So such types are required. And the same Vadati Benif zone, I have explained that into simple part, right? So such terminologies you should be knowing when you're reading your geography. So these all are basics in your GS, and you should dig them if you are reading as that in optional. Is that clear? So this is something where you should remember. So one is interplate and one is intraplate. So the earthquakes in the Himalayas, they are interplate earthquakes. And the earthquake in Maharashtra, that is intraplate. The earthquake in the Koyna Dam is intraplate. Is that clear? So divide the content. So wherever when you find them, the surface part or the things which are important, you segregate them and read them. Intraplate, interplates, Koina episode, all these are very, very important. See, Benif zone and Varti Benif zone. Varti Benif zone. So they are your geography part. They are your optional geography part. Any areas where the ocean plate are subducted beneath the earthquake. So we refer them as Benif zones. So Benif zones are the areas where earthquake focuses are dominant. Focuses are dominant. We refer that as Varti zone or Benif zone. So active foci are there. More foci, we refer them as Benif zone. This is your geography part, right? Now, all the distribution which I have mentioned here, it is defined on the three belts. Three belts. Is that clear? The same thing, whatever I told, it has been explained here. Read this. Read this. Right. Now, impact of earthquake. What happens when the earthquake occurs? Loss of lives will be there because collapses of the buildings, infrastructure collapses will be there, right? So it will damage the infrastructures. Infrastructures in the sense we talk about buildings, it disturbs the roads, railways, etc. So it damages the infrastructure. Sometimes electric short circuits can take place in the mountain areas or in any regions, and this can lead to fire. Short circuit can lead to fire. Then sometimes in the mountain areas when the earthquake takes place, which leads to landslides like Himalayas. In Himalayas, it leads to landslides. Now, if any mountain is there, if any mountain is there, and in the mountain, if you are having the glacial lake, again in the Himalayas. So when the earthquake takes place, when the earthquake takes there, so that will lead to breaking of that glacial lake, and this is referred as glacial lake outburst flood, and that leads to large amount of flash floods. That leads to large amount of flash floods, and this flash floods are seen only in the Himalayan regions, right? In the Himalayan regions. Earthquake. Whenever earthquake is there, there is possibility that that particular glacial lake may break, and that leads to blow. Then undersea, if it is developed under sea or under ocean, then it can trigger the tsunamis. We'll discuss that later. Now, apart from that, very important thing which is responsible for collapsing of the building is these soils, they are always rigid. The solid structure is rigid or it is solid part. On that, the construction is done. Now, sometimes these soil areas where the water enters, it becomes saturated with the water. So sometimes when it becomes saturated with the water, a chemical aspect, soil combining with the water, and because of the pressure due to the earthquake, so this pressure changes the entire characteristic of a solid, which is having a small amount of water or saturated with the water. So because of the induced pressure, the soil which is saturated with the water, which is rigid, it loses its rigidity. It loses its rigidity and it starts flowing like liquid. It starts flowing like liquid. And this characteristic of a soil, when it loses its rigidity and starts flowing like a liquid, we refer that as soil liquefaction, soil behaving like a liquid characteristic. We refer that as soil liquefaction, right? Soil liquefaction, right? So remember this soil liquefaction. So this is where it is rigid soil, and this is where we find that it loses its rigidity. Loses its rigidity, and this leads to collapsing of the buildings. This leads to collapsing of buildings. And this is referred as soil liquefaction. So that's why in many areas wherever the soil liquefaction has taken place, large amount of buildings will collapse there. Heavy buildings will collapse because of this characteristics, right? So this is called as soil liquefaction associated with the impact of the earthquakes, right? Now, in the context of India, Bureau of Indian Standard has made a data which says that around 59% of the India is vulnerable for earthquake, and it has divided the zones in India. So before 2002 there were five zones. After 2002 after 2002 now zone 1 and 2 are merged. Zone 1 and 2 are merged. So now we are having four zones. That is zone 1 and 2, which is zone 1. Then we are having zone 3, then zone 4, and zone 5. Zone 5. So at present, India is divided into four zones, and these are based on based on the intensity factor. Based on intensity, right? So BIS means Bureau of Indian Standards. Bureau of Indian Standard. Indian Standard. Right. Now this is where we find the earthquake and zones are there. The entire Himalayan region is zone 5, including the part of the Gujarat, that is Kutch region, which is zone 5. Delhi and surrounding areas are zone 4. Yellow color are which are referred as the regions zone 3. Orange color is zone 4. Orange is zone 4. Yellow color is zone 3. And a part of Karnataka, Tamil Nadu, etc. Karnataka, Tamil Nadu, Odisha, etc., including these areas, which are referred as Zone 2. Zone 2. So when you are drawing your map, remember, Zone 2 includes these areas, part of Tamil Nadu, Karnataka, Maharashtra, Odisha region. Also, the northwestern part, including the central portion. Surrounding that is Zone 3, entire Himalayas and Kutch region of Gujarat, Zone 5. So, this is what you should remember in the context of earthquake. Entire India is divided into four zones, right? And this is the percentage wise. Zone 2 makes around 41%, Zone 3 makes around 31%, Zone 4 makes around 17%, Zone 5, which makes around 11%. Zone 5 along Himalayas and the Kutch region of Gujarat. Region of Gujarat. Is that clear? So this is the India's vulnerability. Vulnerability of India. Right. Now the major reason for the Himalayan earthquake is it is a region where Indian plate has subducted or subducted beneath the Eurasian plate. It is Indian plate which are subducted beneath the Eurasian plate. Eurasian plates here. Is that clear? So don't make in-depth analysis. Just understand where and these. So Delhi and those areas are in zone 4. So last time or in the beginning of this year itself, we had experienced the earthquake in Delhi and also simultaneously in the Nepal region. Right. So this is called as vulnerability, and this is as per National Disaster Management Authority, NDMA. Is that clear? National Disaster Management Authority. Next is earthquake hazard mitigation. Now, mitigation, as there is no early warning system, as there is no early warning system, no early warning system. So, only way is preparedness and mitigation. Preparedness and mitigation. The first one is in the context of ministries, Ministry of Earth Science, MEOS, is referred as Ministry of Earth Science. So this Ministry of Earth Science has set up a network of has set up network of institutions, nodal institutions. We refer them as the National Center for Seismologies. Nodal institutions called as National Center for Seismology. This is a nodal agency. Ministry of Earth Science has set up a network of National Center for Seismology, National Center for Seismology, and this National Center for Seismology is something which is for regular monitoring and dissemination of information. For regular monitoring and dissemination of information. Dissemination of information. And hence, it will provide some information, knowledge, so that preparedness can be done. So remember, Ministry of Earth Science and National Center for Seismology, which is a nodal agency. Then vulnerability map. And this vulnerability map, where the Bureau of Indian Standard has classified the entire India into zones. Four zones. And this will help us to understand, regulate, and restrict certain settlements or construction activities. So that is also very important. Then effective dissemination of vulnerability risk information. Now this plays an important role, and this can be done by different ways. It can be done by different ways. Like we have many apps are there. Like in the context of India, we have the maps like India Quick, India Quick, and we also have the apps called as Sagarwani, Sagarwani, and also the alert systems. We have alert systems. So recently, the alert system has been developed by NDMA, National Disaster Management Authority, in collaboration with Google. And this alert system is passed to the mobiles, to the mobiles, right? So vibrations you have experienced in your mobiles, which gives the news or message regarding the earthquakes. So hence, it is effective dissemination of vulnerability risk information by using India Quake app, Sagarwani app, alert system, etc. They all work with GPS and other technologies, right? Apart from that, it can improve. It can improve if we make a successful launch of NISAR. NISAR. So it is about future. In future, if this NASA ISRO synthetic aperture radar is there, so it can give some inputs about the earthquake, because NISAR studies the movement of the land, so help in identifying earthquakes, landslides, and also volcanic activities. So this NISAR can be very helpful in identifying earthquakes, volcano, landslides, etc. Right? So which can be a game changer in disaster management. Then we are having structural and non-structural measures, right? So when we talk about structural measures, we have to make sure that the earthquake resilient infrastructure should be there. Resilience infrastructure should be there. Resilience means it should resist and it should recover quickly. And in this context, India has made a very strong move. India has developed a network which is very worth and very significant in the context of creating infrastructures which are resilience for the earthquake, which are resilient for the earthquake. And this approach of India, can anybody name that? What is that India has created, which is well versed in the global part and which is very predominantly known in the global parameters, which talks about resilient infrastructures, engineering knowledge, resisting buildings, recovery buildings. So, which is that initiative which has been started by India, current affairs, which has been started by India and which is very important in the global parameter, not only in India, in the global parameters. And it was introduced during one of the COPs, right? One of the COPs. So, such types of questions you should remember. So it is something called as Coalition for Disaster Resilience Infrastructure, CDRI. Coalition for Disaster Resilience Infrastructure. Coalition for Disaster Resilience Infrastructure. Very important one, CDRI. So it can be helpful in not only earthquake, even in the extreme weather conditions, cyclones, etc., wherever we find. So it is about having a strong structural. So it gives a standards, building standards. It defines the codes, etc. Right. So this is what you should remember when you talk about structural. Non-structural means it talks about awareness, leadership, etc. Then rescue and relief operations. Rescue and relief operations, because we don't have early warning systems here. We don't have early warning systems. So hence we have to depend on these things. Right. Now, earthquake hazard mitigation. Next is the six pillars of earthquake management. We always find that if you take an example of Taiwan earthquake. So this Taiwan earthquake, which was in the beginning of this year, 2024, some 30 years back, when the earthquake struck in Taiwan, when the earthquake struck in Taiwan, 30 years back, the losses were very high. High losses were there. The deaths were more. In hundreds, the deaths were there. But the same magnitude which struck in 2024, the deaths were less than 10. The losses were less than 10. Less than 10. Why? Because Taiwan has developed building standards. It has developed resilient buildings. It has developed resilient buildings. It means that these buildings can resist to the earthquake, or they can recover quickly. Hence, the casualties have been reduced. Apart from that, they also made the arrangement, modernization, restructuring of the old buildings by using the iron windows, steel windows, etc. And we refer that as retrofitting. We refer that as retrofitting. Retrofitting. And earthquake resistant construction, that is resilience. Resilience. So these two were responsible for reducing the casualties in Taiwan. So hence, we should always have earthquake resistant buildings. Then we should always strengthen those buildings by using retrofitting. This is called as retrofitting. Retrofitting. Strengthening the buildings. Then regular enforcement. Regulations means restricting certain activities, and enforcement of laws. Enforcement of laws. So many laws are there, they are only in the papers, so we should use them in that. Then creating awareness among the people. Awareness and preparedness. Why? Because in the context of earthquake, there is no early warning system. As it is having no early warning system, so hence we should create an awareness among the people, like what you should do when the vibration starts, when the shaking starts. You should come out of the house. You should not stay beneath the tables. You should not stay beneath the cots, etc. You should come out of the house. Safety measures, what you have to do, what activities you have to do. So we refer them as awareness and preparedness. Then capacity development, capacity of individual, society, etc. And this can be done by education, training, research and development, and providing them international knowledge in the form of documentation. So capacity development reduces the vulnerability. It reduces vulnerability. Vulnerability. Right. And last one is emergency responses. Emergency responses. So this emergency responses can be in the form of relief, rescue, etc. So that the losses are not death. So six pillars of earthquake management are these, which includes emergency response capability, capacity developments, awareness and preparedness, regulation, and active strengthening. Is that clear? Okay. Now, in the context of India, in the context of India, we always find that the earthquakes are dominant. In context of India, the earthquakes are dominant. But why we are having major losses? Why the losses are there? Or what are the critical areas where we have to focus? What are the areas where we can focus so that these losses are reduced? Losses are reduced. We refer that as the critical areas of concern. Critical areas of concern by which we can reduce the losses. Now, these are very simple. The buildings which you are constructing in the earthquake prone areas, they have to be constructed by a specialist, an engineer who has very good sound knowledge of constructing the buildings which bear the shocks, which is having certain types of the engineering capacities. A normal measure or normal masonry cannot construct that. So hence there should be a proper aspect of providing license to those engineers who are very well versed in constructing the buildings in the earthquake prone areas. Only they should be given the priority to construct that. But in India, we find that every person who is a mason, a mestri, will start constructing the house even in the Himalayas. So we don't have strong regulations to check that which person is constructing, whether he is qualified one or whether he is having the knowledge base of constructing the earthquake resilient infrastructure. So these things are to be taken into consideration. That is that absence of licensing of engineering and masons. Large damages are because of this. Then lack of awareness among the various stakeholders about the seismic risk. Many people, they don't know that they are staying in the seismic areas and what precautionary measures they have to do, what to do, right? So if any vibrations are there, what are their responsibilities, how they have to behave. So this has to be taken into consideration. Then inadequate monitoring to the structural mitigation measures. In education, in engineering, we don't have a systematic syllabus which talks about development or making the construction of earthquake resistant buildings. Then lack of formal knowledge. Then absence of earthquake resistant features in the engineering construction. Then we don't have preparedness and response capacity. And these are the conditions, these are the things which are something making huge impact on the increasing of the vulnerability in the context of India's earthquake. Is that clear? So please remember these points. We refer them as critical areas of concern, right? This is all about the earthquake and its concern, right? So we'll end up the class today. So tomorrow we'll take up the point associated with the tsunami. And as we have completed more portions, so only tsunami is left out. So tsunami and man-made hazards will be there. So tomorrow I'll take up previous year questions. Few questions I'll take up tomorrow. I'll take up the previous year questions because by now you are having a good amount of content in your mind, and that content will help you to make the understanding of the way in which the answers are written. So tomorrow we will be taking the previous year questions, and that will have some impact also. They will have certain sense also because you are having large idea. So broad base is there in your mind that what is risk, what is crisis, what are the events, and based on that, if I discuss previous year questions, then that becomes a framework for you to remember them and keep them into a huge content wise, right? So we'll discuss that and tomorrow I'll complete that. If anything is pending, I'll take 1 hour extra. If anything is pending, I don't want to complete the class in hurry bari. I don't want to complete the class in hurry bari. So If at all, if it is missing, then I'll take 1 hour extra. Maybe on Saturday I'll take extra, but I don't want to complete this course in hurry bari. I want that all the aspects of the geography, all the aspects of this should be understood by a average student as well. So it is not for only the beyond average. Even the average students should also understand these earthquakes and all those parameters. So don't get much stress. It is your confidence, it is your belief which can lead you to the success. It is not about big things, it's not about the big perspectives. And the classical example of this is, if you have read or if you have seen through the matches, World Cup, Afghanistan, average or less than average team, because of its determination, it is responsible with its thoughts, with its action, with its belief. It defeated Australia, it defeated Bangladesh and entered into semi-final. It's a history which has been created. So if you determine and if you work on that, nothing can stop you to achieve the points. And there are many vital examples of that. So don't think yourself less than average, below average, and deviate from your preparations. You make a strong decision, work on that carefully, execute every step. You may find downfalls, you may find failures, but don't disheartened when the failures are there. You should always focus on your approach. So, whenever such things are there, you can think of these incidences like an Afghanistan, which can defeat the mighty Australians and which can reach to the semi final. It is not a chance factor, it is the determination, it is the strategies, it is the belief which they do in themselves. So your beliefs, your thoughts, your execution will reduce the difference between the potential and reality. So please believe in yourself, work smart, work hard, spend some time extra, believe in something, believe in something. See, if they start working without having the assessment from their coaches, it would have been not easy for them. I'm not telling that you believe or you should blindly follow everything. You have to understand certain aspects which is explained by the mentors, given by a faculty. So you should take the positive aspects of faculties, positive aspects of the mentors, which will help us to develop your own strength. So please remember these words. Don't get much disaster. Believe in yourself. Conquer your fear. Execute what is there in your mind. Be transparent. Don't waste your energy. Develop that into a good quality effort here. So by that, we'll conclude the today's class and we'll meet up tomorrow. Till then, take care. Bye bye.